Morning, everyone. Nice job getting first, Azra. Morning, Hike. Morning, Charlie. Morning, Ava. Morning, Sammy. Homer says good morning. Who's Homer? I'm assuming that's going to be a dog. Morning, Ryan. Just fixing something on my Chromebook. Your hedgehog? You have a hedgehog? You don't have a hedgehog. No, you don't have a hedgehog. You have a hedgehog and its name isn't Sonic? I'm gonna need... What? That's crazy. Hi, Logan. Alright, so in period D today. Nothing is due. You had gravitational force and space due back on Tuesday. Didn't get it in. Should have gotten it on Wednesday. Did post something new, scratching the surface. We'll get to that in a few minutes. That's going to be pretty much the rest of the year right there in terms of science content. Alright, we are transitioning from astronomy, Greek for star, astro, to now geology, studying about just the Earth itself. So we're going back to the Earth. Kind of wish some of this information was done a little bit in a different order, but I know other 8th grade teachers wanted this order. We'll go with it. We're going to go back to the Earth. So we did weather, we did climate, did space, now to the Earth. We're going to have another unit test. So I had that question asked already in a comment on Classroom. It would have taken, I feel like it would have taken up too much time that was limited already due to distance learning to prep for a unit test and then take the unit test. So, we could have done one for space, but it would require a little more information, a little more time that we didn't really have. And I wanted to add in something on the Earth. And this is a big document that's really going to get in depth on the Earth. So here's my problem. We only have 3 instructional days, really, every week. You guys get a Friday for AC Lab, and you guys have either a vacation or a teacher day off. So there's really only 3 real school days for you during the week. So I can't fit in everything I need to fit in. So no, there's going to be no unit test. Instead, I was going to have you do a CER. But that CER requires knowledge on galaxies and gravity together. We didn't have time for all that, so I cut the CER out. So now you're stuck with this document. This is your last document. Alright? DNA 24, there's a picture of me and Homer because he said hi. I will have to double check. I will definitely be going there. Alright, so today's agenda: introduction to scratching the surface. This big document. It's a big document, so unit tests being multiple choice and, you know, a little bit of justification, they're hard because there's a lot of information, but it's not a lot of, I don't think, a lot of work to type in a couple sentences or a sentence for a justification. This is going to require a little more obvious information. We're going to explore the Earth's layers to start, and you're going to do some research on the layers. I could give you a reading on the layers, but I feel like it'd be more active and more helpful to your skills if you do a little bit of research and practice those research skills again, right? So we are going to research the 4 primary layers of the Earth, and I'll go in depth on some other types of layers. Alright? A little rainy. But first we'll start with our fun fact today. Fun fact number 3. If Betelgeuse exploded, which means it transitioned from a red supergiant to a supernova, it would light our sky continuously for 2 months. And it would also be visible during the daytime. It could happen anytime, within a couple thousand years, tomorrow, or even right now, outside. So, about a month or two ago, astronomers started to see Betelgeuse in Orion start to dim. And that dimming would be coinciding with the ending of fusion and the transition of the core collapsing due to gravity. And astronomers were like, it's still a little too early for Betelgeuse to really go supernova. You know, we say relatively soon, we really mean within a couple thousand years. We don't really mean now. So people were seeing this happen, people were getting excited. But then Betelgeuse then, about, I think in March, started to brighten up again. And what they think happened is Betelgeuse kind of burped a little bit. It kind of gave off some gas from the system, and that gas kind of obscured our view from our view to the star, and looked like it dimmed. It went in front of the star, just like a planet would go in front of a star, transit. So that gas cloud kind of made it dim. So it's not going to go supernova right now, but it will relatively soon in terms of cosmic timescale. All right? So a little connection back to talking about stars. I'm going to do rocks next week. Scratching the surface. Let's open this up. So right away in the document, I tell you there are 4 layers to the Earth that we're going to concern ourselves with. The most exterior, the outermost layer, is called the crust. Underneath the crust you have a mantle. And underneath the mantle you have a core. The core of the Earth is in 2 parts. There's an outer core and there's an inner core. Okay? When you did your tour of the solar system research for your planet, you had to do a little bit of research on the interior, right? So this interior and the terminology shouldn't be that foreign to you. You should have some knowledge of what a crust is. And think about a crust of a pizza, the outer edge of the pizza, right? The mantle is in the interior, core being at the center, okay? So the Earth has sub-layers within those layers, like the outer core and inner core. They're sub-layers of the core. There's also sub-layers in the mantle, but we're not really going to get that in depth because I don't really have the time. But I want to introduce to you these 4 layers. Okay, we're literally scratching the surface of the Earth and going down deep. All right. So what your focus is today is to do some research on the background of these 4 layers. We're going to start from the interior and work exterior. Interior means inside, exterior means to go out, right? So you're going to open a new tab. You're going to keep this document open. You're going to search for the inner core of the Earth. Remember that Google itself is not a source. It is a tool, okay? It is a tool. It is not a source. If you're going to build something, all right, you're not going to build a little doghouse with a hammer, like made it out of hammers. You're going to need wood, right, to build a house, or maybe a little hut for a hedgehog. You're going to need material. You're not going to make it with scissors, all right? So Google itself is a tool. You can't build your research based on Google. You can find information with the tool. All right? You can build with a tool. You can't build something out of a tool. You'd love that. Research the properties of the inner core and cite that information below in the middle column. Reliable and accurate sources tend to come from URLs, that's up above, right, that end in .org, .gov, or .edu. The best places to kind of see good geological information is going to come from the NASA of the Earth, the USGS, United States Geological Survey. or also from NOAA too, might have some good information, even though they more or less concern themselves with just pretty much the ocean. But the ocean floor is going to be involved when we talk about how the layers influence the crust. Alright? So you're going to Google inner core and you're going to look for information on what's its average temperature, how far down is it from the surface, below your feet, how far do you need to go to reach the inner core. So the depth from the surface, its composition. So what materials, all right? What molecules, what compounds are in there? What state is it in? And it's going to be one of three. Can't be plasma, because then the whole Earth would be a star. So no plasma. And then any other information you want to provide. So temperature, give it to me obviously in degrees Celsius. Here, let me make this a different color so it's a little more obvious. No, I don't want to make the line a different color. No, I don't want to fill it. Where's... It's over here, because I'm so zoomed in. Degrees C. Depth from the surface, you're going to give that to me in kilometers. Composition. I want to know elements, molecules, compounds. It's easy for the inner core, so don't get scared. State of matter, so we're looking at solid, liquid, or gas. Which one is it? Not just iron, Rainy. Not just iron. And I mean, can the core really be a gas? I mean, only the atmosphere is a gas, right? So is it solid or liquid? Is pretty much what the question is going to be. So I can actually do that. Well then, actually, I got my cores mixed up. Inner core, yes. Outer core, when you go down below, a little different. And then any other information, just copy and paste your source in here. Alright, there is no restriction on what sources you can use, how many times. Alright, so just, if you can find it from the same source, that's fine. Just focus on the inner core. So start doing the inner core right now. And give me questions as you're trying to search for the inner core. Okay? Don't concern yourself with the other layers just yet. I want to make sure we're on the right track. Okay? So, let's say I go NG USGS and I look up inner core. Should probably put an E on that. Open some of these up. Inside the Earth. The size of the Earth. Let's see if I zoom in a little bit. The size of the Earth, which is in diameter about 13,000 kilometers, was known by the ancient Greeks, but was not until the turn of the 20th century that scientists determined that our planet is made up of three main layers: the crust, the mantle, and the core. Okay? This layered structure can be compared to that of a boiled egg. The crust, the outermost layer, is rigid and very thin compared to the other two, so kind of like the eggshell. Beneath the oceans, the crust varies a little in thickness, generally extending to only about 5 kilometers. So that's kind of giving you information about the crust. So even if I don't use this for the inner core, I can at least keep this link up and open for the crust, because, like I said, the crust is in the list. Just we're not concerned with it right this second. Okay. The thickness of the crust extends. Base of the crust can be as deep as 100 kilometers. Like the shell of an egg, the Earth's crust is brittle and can break. Okay. And so we have a cutaway. So this right here is giving me a little bit of information. All right. The asthenosphere is the layer that is in direct contact with the crust in the mantle. We're not really going to get into that just right now. The lithosphere is, again, the upper part of the mantle and the crust. But right here, the core. The inner core starts at 5,100 kilometers down. So I can provide the depth. Okay? Oh, it's not working. So automatically I can already cite this source. So it gives me the depth. Because again, I'm looking at this picture. And the depth right here is 5,100 kilometers. State of matter, it's a solid. So I've already gotten 2 out of the 5 things I'm looking for. Alright, so I know the depth, I know it's a solid. How about its composition and its temperature? Below the crust is the mantle. Okay. Scanning, I'm looking for words that I need to find for the core. Mantle. Center of the earth lies the core, right? So I'm scanning for words that I need to look for. At the center of the earth lies the core, which is nearly twice as dense as the mantle because its composition is metallic, an iron-nickel alloy. So you got to remember a little bit from 7th grade, hopefully you guys talked about how you can have a heterogeneous mixture or a homogeneous or a homogeneous mixture, all right, when you have a non-pure substance, you have a mixture. Alloys are metallic mixtures. And so we're looking at an iron-nickel alloy rather than just rock in the core. Unlike the yolk of an egg, however, the Earth's core is actually made up of 2 distinct parts. So this is just the total thickness. This isn't the actual depth. The depth is in the diagram up here. I would use this to help you do even the outer core too. As the liquid outer core, solid inner core. As the Earth rotates, liquid outer core spins, creating the Earth's magnetic field. So it's getting into the magnetic field. That's something we could maybe add in for an other. So as the Earth rotates, liquid outer core spins. Maybe we could use this for the outer core, because it's mentioning the outer core. And then it's getting into the plate tectonics, which we're going to talk about later, but not right now. So I got an iron-nickel alloy for both cores. That doesn't really tell me what the inner core is like. So another one from the USGS website. 3 main shells, very thin, brittle across the mantle and the core. Core and mantle are about equal in thickness. The core actually forms only 15% of the Earth's volume, where the mantle occupies 84%. So the mantle is the thickest layer by far. The crust, the mantle, and the core. The core was the first internal structure element to be identified, discovered in 1906. Help explain Newton's calculation of Earth's density. So we had earthquakes, and the seismic waves determine different densities of the layers. We're going to talk about that in the extend section. This is kind of getting ahead of ourselves. I'm just looking for basic information about the core that I asked you to. Don't need to talk about waves. Depth is surface towards the inner core, Downey. Yes. Do not give me the thickness. Give me the depth. So, this website, if I Google USGS inner core, I think it's the first one. Nope. The second one gives me this diagram that I can use and cite the depth. This is depth. To go from the crust to the center of the Earth is 6,378 kilometers. but I want to know when it starts, which is right there, 5,100 kilometers. So I want depth. I don't want thickness. See, this is thickness. Structure of the moon. Data from earthquake waves, seismic waves, rotations, and the inertia of the whole Earth, magnetic field dynamo theory. So saying that a liquid outer core rotating around a solid inner core, moving metal creates electricity, magnetism, and laboratory experiments on melting and the alloying, so mixing, of iron all contribute to identification of the composition of the inner and outer core. The core, again, the two layers together, are presumed to be composed principally, so mostly, of iron, with about 10% alloy, and then 10% alloy of oxygen or sulfur or nickel. So, a lot of iron. Like Randy's finding. And I'm just pasting in the links where I find information. This one isn't loading for some reason. Inner core composition. Yeah, I'm trying to fix it. I don't know why it's doing that. Innercore, no. Nat Geo, wonder if they got anything good. Earth's interior, Nat Geo. The inner core is a hot, dense ball of mostly iron. There's a radius, which is thickness, which we don't need. Temperature is about 5,200 degrees Celsius, and the pressure is like 3.6 million atmospheres. It's like 3.6 million atmospheres pressing down on you. That is a lot of pressure. The temperature of the inner core is far above the melting point of iron. However, unlike the outer core, the inner core is not a liquid or even molten. The inner core's intense pressure, the entire rest of the planet and its atmosphere, prevents the iron from melting. The pressure and density are simply too great for the iron atoms to move into a liquid state. So this is a great source. And it goes into the other. Okay? The other being, why is the inner core a solid? And so you can answer that because we go back to this, not this, this one, and it's due to the intense pressure. It has to be a solid. It cannot be a liquid. So we've kind of found, using three sources, especially Nat Geo, that one was a good one. Temperature is 5,200 degrees Celsius. The depth, 5,100 kilometers. Composition is mostly iron. It's in a solid state. And it's a solid because of the intense pressure preventing iron atoms from moving around. So that's how I would have attacked the inner core, researching, finding information. USGS and Nat Geo are going to be your friends. I don't know if Noah would have anything. Inner core structure of tropical cyclones? No. Cloud systems? No, they're just referencing the core of a hurricane. So that's the inner core. No one really has any questions. Hopefully not struggling. Which seems like it's the case, that you're not. There are 3 other layers. There's the outer core, there's the mantle, and there's the crust. I've already kind of talked about the depth, temperature. Obviously, you're going to have the temperature of the atmosphere, really. Mantle depth, mantle temperature, other features. So you could just copy and paste what's in black and then just type over what you've done for that core. And then just paste your sources, and that's all you're doing. You're just doing the explore section today. 4 layers. What's unique amongst each layer? So we can get a better picture of what the Earth is organized as. Because once we figure out how the Earth is organized, we can figure out what effects that organization causes. Things doing with the Earth that we've heard about, or maybe even experienced. Earthquakes, magnetic field, that tectonic plates, these things moving on the crust. These all have to be based on what the layers of the Earth are. Is there a DNA? Mr. Eric, there hasn't been a DNA all week. Is that the scratchiness? I think it's the cable. Yeah, I can hear it on the stream now. I use the mic because I can hear you better, and you guys can pick me up better too. My webcam audio is bad. So that's why I use the headset. Can't hear me right now? Yeah, because I haven't said anything. You are doing the other parts. You can go on and do outer core, mantle, and crust. Well, I dropped the gain so that you guys wouldn't hear the crackling. I dropped the gain because I didn't want you guys to hear the crackling, but I guess I have to boost it anyway. Eee. You are doing the other layers, outer core, mantle, and crust. Only doing the explore section. Don't go any further. I see that gain is way too high. Hopefully that's a little better. So kind of while you guys are working, quick announcement about the Mighty Meetup. So last couple Fridays, not last Friday, because that was a vacation day, but the Fridays before that, we did have a Mighty Meetup, hang out in Google Meet, do different activities. Ryan cheated at categories. Kidding, Ryan. Maybe you watched a movie, you did something, Mr. Howman, Fun Friday, or Miss Grant. We're not going to do it tomorrow. Not do it tomorrow. I don't know about the following Friday, so next week, because a lot of June is going to be team building, end of year stuff. So you're not really going to have as much content as you've had in terms of science, social studies, ELA math. So we might hold off on some of that Mighty Meetup stuff for in June as we kind of wrap up the year. All right? So there is no Mighty Meetup tomorrow. If you are missing work or you want to revise, send an email, go to Remind. There's no stream, but I can still help you out. What else do I want to say about that? So, again, if you owe work, you want to revise, Friday's a great time to do that. If you're all caught up, you're good, you check Aspen, doing well in all your classes, enjoy that day. I heard it's going to be some nice weather tomorrow. Completing this whole thing? No, you are not doing the entire document. You are doing the Explore section, Rainey. The Explore section. Research on the inner core, which I tried to help you with. Research on the outer core, mantle, and crust. That's it. Stop here for Thursday, 5/21. Stop. I think I might use Nat Geo and USGS websites for my research. That is a beautiful thing. Highly recommend that, Downey. Googling USGS with your layer or Nat Geo and your layer will be helpful. I haven't heard the crackling. Is it still happening? Sounds like a you problem, Eric. Haven't gotten any questions on reminds, I don't think. Let me just double check. Sometimes notifications don't go through. Yeah, no questions on reminds, no questions by email. You guys seem to be on track. If you have questions throughout the day, let me know. Hopefully I put you on a good path using USGS and Nat Geo. Alright. Obviously, if you don't know what these links are, you can almost pause the YouTube video here after the stream's done. You can kind of take a look at that. But for that Nat Geo one, I just went to inner core composition, and it was the first Nat Geo one that was in the list. Remember, the links are right here at the top in gray, and well, the website, the URL, and then the link is in blue. So, all the Google stuff from study.com, Wikipedia, space.com, and then Nat Geo right there. If I Google inner core composition Nat Geo, it's the first one. If I Google inner core Nat Geo, it's the first one. I wonder if I Google mantle. Oh, look at that. I bet it's all kinds of cool stuff about the mantle. Gives the thickness, not the depth. Upper mantle. Transition zone. Lower mantle. I just want basic information. Nat Geo might give you more information than you need. Which means then you go back to USGS. Alright? Let me know if you have questions. I'll be around to answer. Have a good Thursday. And have a good weekend if I don't hear from you. Good Memorial Day weekend. That's right, I had to look up Homer. Hold on a minute. Hold on. Which? Oh, not on the stream? Oh, come on. Alright. That's Azra's business. I'll check later. Bye, Randy. Bye, Azra. Bye, Charlie. Bye, Downey. Bye, Ryan. He got cut off on a second page. How cute. Yeah, he's pretty cute, Rainy. Alright, have a good weekend, guys.